Let's be talking about them capillaries and how they work and how things work in capillaries. It's going to be a good time, wonderful time. We're going to be talking about diffusion, transcytosis, and bulk flow. Hopefully you all remember from AP1, diffusion is just grabbing something or allowing things to get into the cell via channels, via mediated diffusion, things like that. Transcytosis is taking a glob of stuff like phagocytosis and then pushing it off to the other side. Well, bulk flow is, well, a little bit more complex, to say the very least. So diffusion, we got ourselves this type of thing going on in the body's capillaries. You got glucose going out, you get oxygen going out. The double A means that it's amino acid. You got steroids going out. You got all that different stuff going out into the tissues. Well, carbon dioxide is going in and getting rid of. They go against with their concentration gradient. You got more CO2 in the tissue, so it's going to go into the blood. You got more glucose in the blood, so the blood, hopefully the glucose is going to move out into the tissues. Same thing with the other ones. Transcytosis is kind of what I discussed earlier. It's you're grabbing the protein, the cell's grabbing it, putting it into a vesicle, and then moving it across to the other side, and then releasing it into the interstitial space. Bulk flow, well, there's a couple of things that we're running with. It's really the filtration and reabsorption. And there's two physics-based factors that are playing with it. The hydrostatic pressure and the osmotic pressure. Hydrostatic pressure is just, you got, for a lack of a better way, it's that blood pressure really pushing on that water, pushing it in. Well, osmotic pressure is how much of a draw does liquid have? How much does a draw have? You got two liquids involved. You got the blood, which I have labeled with a B, and then the interstitial fluid, which I have labeled with IF or if. And there are two places involved, the beginning and the end of the capillary. Bulk flow, again, hydrostatic pressure, let's pull that out. If you have a high blood pressure and there's low pressures on the outside, that high blood pressure is going to push out liquid. Stuff is pushed out from a high to a low. Now, osmotic pressure depends on which one wants more fluid. Does the blood want it to hold on to it more? Does the interstitial fluid want to hold on to that stuff more? Kind of like these two little poopies. Which one do you think is going to hold on to it? So filtration and reabsorption, you got two liquids involved, the blood again, the interstitial fluid. And how you do this calculation, which you don't really have to fortunately do right now, is this guy right here, the net filtration pressure, which is NFP means net filtration pressure, BHP, blood hydrostatic pressure, IFOP, interstitial fluid osmotic pressure. And then you got the BCOP, which means blood colloid osmotic pressure, and the IFHP means interstitial fluid hydrostatic pressure. These two, the first two ones that aren't minused away, favors interstitial fluid. The blood hydrostatic pressure, if it's really high, is going to push stuff out, while the interstitial fluid or osmotic pressure is going to be pulling, most likely going to be pulling on stuff to get it out. And the other two that's being minused is going to be favoring more of the blood. So the blood osmotic pressure, how much does the blood want to hold on to the liquid? And then the interstitial fluid hydrostatic pressure, how much pressure is the interstitial fluid pushing out? So if we were to apply that, we're going back to here. The net force pressure at the beginning of the arterial, why is it labeled arterial? Oh, arterial end, okay, I get it, is the beginning of that capillary. And the net filtration pressure, the blood hydrostatic pressure and the interstitial osmotic pressure is much higher, so it's pulling it, and it's pulling it well. But at the end, it's starting to try and favor pushing stuff back into the blood. So that's like the hydrostatic pressure of the interstitial fluid is starting to be a lot stronger than over here, so it's going to push it out. And the osmotic pressure of the blood is going to say, hey, give me that stuff, and it's going to start taking it. You will notice that at the very end that there is a net reabsorption of -9 millimeters, usually mercury, and at the beginning it's a push out of 10 millimeters mercury. A positive number means that you're pushing pushing stuff out. A negative number means you're reabsorbing it. You'll notice that 10 minus 9, there's 1 millimeter mercury missing, so there's still some fluid hanging out here. There's another way that it's reabsorbed that we will discuss next week. Via the lymphatic tissue. I might as well just tell you that. It's via the lymphatic tissue. Now, the things that affect blood flow. This is stuff that we're actually going to talk about for blood pressure and all that stuff. So I'm going to go ahead and pause there because I'm pretty certain this good old-fashioned Starling's law of capillaries is quite enough.